In this example, I'm going to compute the derivative of this function, x plus 1 over x plus 1, but we're going to compute the derivative of that function by the definition of the derivative, the limit definition of the derivative. Okay, so let's remind ourselves, what even is that? So we're investigating the limit as h goes to 0 of f of x plus h minus f of x all divided out by h. Okay, now I have a specific f of x and I want to feed that into here. So in other words, for our specific case, we're going to say, okay, the limit as h goes to 0. We copy that down every time. Make sure you don't forget it. I can go and have a big long quotient. I'm certainly going to have the division by h. But first I need to do f of x plus h. Okay, so this function here, this f of x, reads any input, you take the input plus 1 over the input plus 1. So for example, f of apple is apple plus 1 over apple plus 1. Now, the specific input we are putting in is we're putting in x plus h. So I'm putting in x plus h there, which means there's an x plus h in for this x, and there's an x plus h in for that x. So watch how it occurs. What I'm going to get is, first of all, an x plus h. Let's put a big bracket here, because I think we're going to need it. So x plus h, and I'm going to put that in little round brackets. Then 1 over, I got another x, so it becomes an x plus h when I feed in x plus h plus 1. So that whole thing here is what my f of x plus h is. In the two spots where there were x's, I now have an x plus h. Then I need to subtract off f of x. Well, f of x is just this, so I'm subtracting off an x plus 1 over x plus 1. Okay, so that's my limit definition applied to the specific function that I have in this problem. So this is kind of long and messy. Let's try to clean it up as best we can. I'm going to write the stuff that comes for free first. Let's go and put down the limit as h goes to 0, because we always put that there, and let's just not forget about it. Okay, now looking at this gnarly expression on the top, what can we do? Well, one thing I notice is that there's an x here, and there's another x there. So I can cancel them because they're subtracting. So that x and that x are going to go away. I'm going to have this plus h here, and nothing to do with it. I just can't get rid of it. So I'm going to come along here, and I'm going to have an h. All right. Now, what remains? I have this expression, x plus h plus 1, and I have this expression, x plus 1, and really it's a difference of these two fractions. So how do I do a difference of two fractions? Well, I do lowest common denominator. The lowest common denominator of x plus 1 and x plus h plus 1 is the product of those two things. So I effectively am going to cross multiply. The x plus 1 is going to come up, the x plus h plus 1 is going to come up, and I will get this. So it's going to be a big long fraction in the middle. On the bottom is the x plus h plus 1 multiplied by x plus 1. So that's those two denominators that I have multiplied together. The x plus 1 is going to come up here, so I'm going to have an x plus 1. And then I'm going to subtract off the x plus h plus 1 comes up over here, so x plus h plus 1. All right, and then the whole thing, I'll extend that line out, is divided out by h. Well, is it cleaner? A little bit cleaner, I guess. We've done some stuff, but I still think it's kind of gnarly. I still want to do a bit more work to this. Well, what can I do? Okay, let's investigate. Notice how I have a plus x and a minus x here. Those are going to cancel. We can get rid of those. I also have a plus 1 and a minus a plus 1, so that's a minus 1. That cancels with that. And so I think all that I'm left with here is that there's a minus h up on the top. It's divided by that stuff. That whole fraction is added to the h and then divided out by an h. Okay, now I'm going to do some even funkier canceling. There's an h here, right? After I've gone and got rid of the x plus 1 and the x plus 1, all that this numerator leaves is a minus h. So there's an h here, and there's an h here, which means everywhere on the top there is an h. And there's an h on the bottom. So I can come along, I can cancel that h and that h. Those are the two that are on my top. This one comes with a minus 1. We can't forget about it. But there's an h there and there. That h on the top cancels with the h that I have down on the bottom. Okay, let's see how it's going to work out. So this is going to give us limit h going to 0 of 1 plus. Now what remains over here? I still have that minus h. The h cancels divided by the top and the bottom. That leaves behind a minus 1. So minus 1 all divided by this stuff on the bottom. I haven't done anything with it. It's still there. So x plus h plus 1 times x plus 1. And then when I look at that expression, there's, I think, actually nothing else I have to do, because the whole reason we didn't take h equal to 0 and plug it in, say, on the first step, was that you'd have a 0 on the top and a 0 on the bottom. I had to do more algebra before I could plug in h equal to 0. But now there's no division by h. There's no 0 on the bottom. So I can just take the one remaining h, which is right here, and I can send it to 0. And so what do I get? I get 1 plus minus 1 divided by x plus 1. And there's an x plus 1 there. When h goes to 0, there's an x plus 1 there. And so I square it. So my final answer is 1 plus negative 1 over x plus 1 squared. Just a couple little points about terminology. Notice I have an unbroken chain of equalities all the way through this. Note that I have a limit as h goes to 0 for every single one of these except the very final one, which is when I have evaluated the limit and actually set h to 0.